You. I'm very excited to be here today to open up Serverless Days 2. I love these community events. They're so incredible to see community come together, to learn from each other. I've seen a few of the speakers today who are going. I've had the chance to see them previously in other engagements, and it's a fantastic lineup that we have. Let me just make sure that we're good on projecting. So today I wanted to kind of open the day off by sharing some about how I've noticed or what I'm seeing happening around serverless around the world. And part of that is going to be talking about where serverless is today, where I think it can go, and why it matters for every single person in this room. And I'm hoping, I got this to work earlier today, I had to just unplug and plug it back in a few times. So I'm going to keep doing that, and I'm hoping that we get my screen showing up here in just a second as well, which I'm not right now. Okay, there we go. All right, just want me to do that thing. Okay, so to start with, I actually want to start with a story, because it's early in the day, so let's just tell a lot of stories today. So I want to tell you a story about when I was going to uni. So as was mentioned, right now I am a product manager at Microsoft. I work on Azure Functions, so I'm on the engineering team based out of Microsoft headquarters in Redmond. But before I worked at Microsoft, I went to uni, and while I was at uni, I helped run a startup with my neighbor. And it was a tech consulting startup. What would happen is like businesses that had 10, 12 employees that had technical needs, but they didn't really need to hire someone full-time. They would contract with us. We would go in and hook up all their computers or whatever else it might be. So you could think like dentist offices, orthodontist, law firms, those types of smaller businesses, we'd go in and set them up. And one of our largest clients was actually the prison system in my state. So the prison system contacted us and they're like, hey, Jeff, we want you to come and work on all of our machines. But actually one of the big projects they had us work on was installing kiosks in each of the prison cells, or really like the prison common areas that they had. And so I remember getting scanned in, getting buzzed to go back into a prison. They had all the cells, and then kind of in a group area, we would install kiosks that looked a lot like this. And I don't think Bruin Kiosk was necessarily the brand that we used, but this was the image I found that looked exactly like what I installed. So it was just a single screen like this. You can see it's locked to actually get access to the computer that was behind that touchscreen monitor. I remember one of the qualifications for this touchscreen monitor when we bought it was that it had to be able to withstand the full force of a human headbutt and not break. So we found it. We found the touchscreen. And all that would happen is it would boot up a super simple version of Windows that would start up Internet Explorer, of course, because it's prison. It would start up Internet Explorer. But there was no URL, there was no back button. It would go into full screen kiosk mode. It had to go into full screen kiosk mode. And it would be an app that kind of looked like this. They could touch it, they could type in their ID, they could order things like snacks, supplies, you name it. Well, we installed this for them, and they've been using it for some time. And one morning I got a frantic call from the warden. And he's like, Jeff, I need you to come in right now. Something's going on. He's like, okay, what's up? He's like, well, I don't want to go into details, and please don't tell anyone about this. But we found that prisoners have found a way to use the kiosks, and they were caught using Facebook on these kiosks. So we need you to come in right now, figure out what's going on, and you've got to stop it. So I jumped in my car right away, and I just remember thinking, like, what in the world? How would they do that? Like, we locked down these machines. There's no USB cables. There's not even a keyboard and a mouse. So how was this happening? In fact, when I got to the prison, I just went into a room for a while with one of these machines, and I was doing everything I could. I tried tapping corners, doing weird gestures, power cycling. Like, is there any way that I can get access to this machine? And I couldn't figure it out. So after a few hours, a guard came over, and he's like, hey, Jeff, one of the prisoners has actually agreed to make a deal, and he's going to tell us how they're using these kiosks to get to Facebook. But none of the other prisoners can know that he's telling you this, because we all know the adage of any prison, which is that snitches get stitches. That's exactly right. So I went, they're like, he's supposed to be in an appointment right now. Go meet him in a holding room, and he's going to tell you what's going on. So I went into this room with him, a super nice guy, and he explained to me, he really was, he explained to me what had happened. And he said, okay, here's what we figured out. If you highlight some text and you tapped around the text that you highlighted, then a little menu would pop up. And in that menu was an option to search with live search. Now, we had worked on the operating system in a way so that this blue little square, that was not showing up. But I guess invisibly, Internet Explorer was still putting it there. And they figured out that they could tap in that area, and it would drop this menu, and they could say search with live search, which would take them to the predecessor of Bing.com. I was like, wow, okay, that's creative. But even then, you're at now Bing.com. You don't have a keyboard and a mouse. How do you go from there to Facebook? And he said, well, the other thing we figured out is that if we highlight just one letter at a time, that you can drag and drop that letter into a text field, and it will copy and paste it. So somehow, they figured out not only how to get to live search, but then by just using letters on that page, went to a search page that had Facebook, just using letters and symbols on that page, drag and dropped their usernames and their passwords, and finally were able to log into their Facebook accounts. And I was seriously astounded. I would have hired that guy on the spot if it would have been different circumstances. But really incredible. And it was such an incredible thing to see how they'd done it. We ended up having to work and figure out how do we edit the registry so that this hack wasn't possible. But it was fun for a lot of reasons. It was a really interesting experience. But one of the things that really stood out to me at that time is I thought it was so amazing that they'd hacked the system. And if there was one web page that they could go to, one thing that they wanted to do, it was to go to Facebook.com. And this was back in like 2006, 2007 when I was going to uni. And if you actually look at the growth of Facebook, you can see that something happened around 2007, 2008, right? These are massive numbers even still at the bottom. These are millions of users. But right around 2007, 2008, this really took off. And Facebook went from being kind of this cutting edge thing, this thing that high school students or college students would use, to something that really redefined the way that we as a society communicate with each other. And you could debate that this growth actually hasn't been a net positive towards society. That's possible. But regardless, it's clear that Facebook was incredibly important in all of our lives. Now, there's a book written by Malcolm Gladwell that inspired the talk title that I use today called The Tipping Point, which is all about how any product, any idea, they have these moments of a tipping point where all of a sudden something changes and it catches on like wildfire. And the reason I started with that story is because I've been thinking about serverless. Serverless has been around for a number of years now. Obviously, it's important enough that we can have community events like this around the world. But I would argue that serverless has not hit a tipping point. It's still pretty early. There's a lot of people who are learning about it, who might not be using it for one reason or another. And I've been trying to figure out, will serverless hit a tipping point? And if so, what's going to make the difference? Now, when trying to figure out, will serverless make a tipping point, I came across some talks given by this fellow named Grady Booch. He is a pretty famous software engineering kind of like architect. He's been around from the early days of object-oriented programming. And Grady has an amazing kind of research thesis that he's given a lot of publishings around and talks, where he talks about the evolution of computing. If you look back from the very first computers to, starting with like the Turing machine and even predating that, to like full room filled machines going to the moon and whatnot, to personal computers and so forth. And he talks about what's been driving that evolution, what dictates what becomes big and what changes how we behave. And he kind of has this thesis where there's two main drivers in the evolution of computing. As we take steps in that ladder, there's two main drivers. The first one is that every time we take a step, we raise the level of abstraction from the step below it. So with the introduction of things like programming languages, this abstracted away a lot of the assembly language that we used to have to care about. Operating systems came around and they abstracted a bunch of the hardware interfaces that used to happen. Now we have cloud services that abstract away much of the underlying hardware. So as we move in this evolution, we're constantly moving up in our level of abstraction and focusing on more and more granular scopes. And the second thing that he thinks is a huge factor is economics. Right? At some point, it becomes less expensive and more economical to have a machine build a factory line of parts than having people on that factory line. And when that crossover happens, things accelerate. And computers take off in a whole new way. It happened with personal computers. It happens with robotics. And he says the same thing is happening today. And when I look at those two factors and I think about serverless, in my mind, it hits these both super cleanly. right? Serverless abstracts away so much of the application architecture that we don't have to think about anymore, and the economics is a no-brainer. Serverless really makes compute become a utility. In the same way that if I'm building a company today, I don't have to go and forecast how much power I'm going to need in 3 years, or make sure that I build my company next to a river or on top of like a coal factory so I can get steam power. I just connect to the power grid. I consume power when I need it, and it's a utility for me. That's what serverless is, the realization of that promise for compute. Compute really becomes a utility. Something that you have a problem, you have a use case where you need compute, you spin up a serverless function, and you have access to it immediately. I really think serverless is going to have a tremendous impact of the landscape of compute moving forward. Now, what's stopping that tipping point? Why, given that it hits these two things, why have we not hit that tipping point yet? And I have a few thoughts. But as I thought about it, I went with that lens of history, and I was thinking about, okay, let's think about that utility analogy. What about something that is so obvious to us today, like power, the power that's powering this stage and my computer and the projector? What was it like when the utility of power was just emerging? So that took me back to kind of the 1890s, right around the turn of the century. And I learned that just like serverless and just like electricity, the history of innovation is the story of ideas that seemed dumb at the time. And there was a time where wiring up cities with electricity seemed dumb in a lot of ways. And there's a time when a lot of people think that serverless seems dumb in a lot of ways. And if you don't believe me, just go to Hacker News, type in the term serverless, open up the comment section for any article that was posted in the last 2 years, and there will be a lot of people who are like, this is dumb, this is overhyped, this is all marketing to get you locked into Amazon or to Azure or to Google. So thinking back, I was like, well, what made the difference? So there were a few things with electricity that were deterrents at the time, things that were preventing people from thinking this was a great idea. So back in the 1890s, 1880s, you had cities like London, cities like New York, where there was a lot of innovation happening in this space, but there was a lot of pushback. One of the big arguments was that electricity was extremely dangerous. People could be killed by electricity. They were killed while installing infrastructure. In fact, it was told that in New York, when they were first laying the power cables underneath the streets, that when horses were walking with their little carriages, that it wasn't uncommon for a horse to just get like really shocked and kind of like stabilized because they were walking on the road and somehow hit something wrong. Power was super inefficient. Gas lights were really bright, and to power up a light bulb and give it the same type of brightness was not a very efficient task. There was also a big pushback that while electricity was interesting, it was really limited in what you could do with it. For a long time, things like AC power, they knew how to make light bulbs work, but they didn't know how to make things like electric engines work. So they're like, yeah, sure, this power thing's fine for lights, but for our engines and everything else, we're going to need something else. So again, I think about in our time right now, if I think about serverless, what are some of the deterrents? A few that people run into are things like lock-in that I mentioned before. This is one of the key times in our evolution of computing where taking a journey in this jump oftentimes means aligning yourself with a vendor. That's a scary world to be in, and I understand why that's a deterrent for many people. There also is the argument that serverless is only good for a limited set of use cases. Hey, I only have so much control over the hardware. These things can only run for 10, 15 minutes max. There's a lot of jobs that I have. I need GPU. I need long-running, heavy, high compute power. I just can't use serverless for that. Cold start, I need more reliability. I can't have things wait too long. And finally, just management. Oftentimes that first function, that fifth function, feels really good. But what happens when you have 400 functions, 500 functions? How do I wrap my mind around it? Now, in the same way that in the slide before, with electricity, we learned how to deal with each of those things. We found efficient ways to transport electricity. And some of them, we never found a way to make it so that electricity isn't dangerous. Electricity is still very dangerous, but we figured out the ways to work with it, to make the most use for it, and find ways around that danger. In the same way with this list, there's many of these that I think are just going to become obsolete in the next few years. Cold start's a great example. Every year, cold start numbers go down. It's a trend that's going to keep happening. In a matter of no time, cold start's just going to go away, right? For these other aspects, like management, I suspect that we as a community are going to need to learn to rationalize, to build tooling to help us think around problems in the space of serverless compute. Now, just to give you an idea of some of the ways that we've been thinking about this, I want to show you some of the stuff that we've been cooking up to kind of think like, how can we think differently about some of these deterrents? In fact, one of the things that's often cited with serverless is that serverless has to be stateless. There was actually, speaking of Hacker News, a blog post about 2 weeks ago. Someone wrote a great blog defining serverless, and they're like, serverless is stateless. It triggers, it runs, it goes away. There's no state. It just blows up after it's done running, okay? So one of the things that we've been cooking on here in Azure Functions is a way to write a stateful function. Now, I'm showing you an example of that right now. This is actually written in .NET. And this is a stateful function. In fact, you're looking at these 35 lines of code. This is an Azure function app. It's a function app today that I could actually run in the cloud. But it's a different type of function. It's going to be a stateful function. Now, the story around this function is, imagine you go to a conference. Imagine like the Microsoft Build Developer Conference. Let's say you want to build an app around that conference. Well, that conference is going to have a bunch of different sessions. Each of those sessions are going to have things like attendees. They're going to have reviews. People can submit evaluations. So I've defined those properties here. You know, I have attendees. If you scan in, it's going to increment attendees. If you submit an evaluation, it's going to do that. I can even have an aggregate, which is like, what's the average score for this session? Now, I can deploy this class as a function app. In fact, right now on my machine, I'm actually going to start this and debug it. Now, one of the things we've tried to do to combat vendor lock-in is that Azure Functions is actually entirely open source. So right now, with this beautiful ASCII art that also appears on my T-shirt, that shameless plug we have at the booth right outside, but it's now running Azure Functions on my MacBook in this case. Now, in this case, the function is this stateful function for a session. And to show you how it works, just here in Visual Studio Code again, I can start to call right now using localhost. And I'm going to call some of these stateful entities. So I have my sessions. Let's say one of my sessions is AZ101, a session that teaches you everything you want to know about Azure. So I'm going to say, hey, get me the state, get me the details about this stateful function for AZ101. I call it, right now it's actually saying I don't know anything about an AZ101, and it's because I've never used that function before. But let's go ahead now and scan a few people in. So I'm going to call another operation to invoke that scan in method. So let's scan in 1, 2, 3 people, right? All those got accepted. And now if I say, give me the information about AZ101, you'll see that I get back information about that function. It says, hey, there's 3 attendees. We don't have any reviews right now, and so forth. Now, the cool thing with this is that you can run this in a serverless way. So to simulate that, I'm actually going to terminate the function. I'm going to close down everything. If I had more time, I would shut down my machine completely and boot it back up. But now when I go ahead and run this function again, when another event happens that triggers it up, in this case I'm going to spin back up that Azure Functions runtime again, I'm going to go ahead and say, hey, give me the current state of session AZ101. And when I make that call, it's going to return back to me the state of AZ101. So it's like, hey, I remember this one. It has 3 attendees and no reviews and a 0 average score. So some of those concepts that have sometimes been blockers or deterrents, like how do I deal with state, I think we're going to figure out ways around that. In the same way that here, you don't see anything here about S3 or Azure Storage. I'm just deploying a function. But in this case, I've said I want this to be stateful, and it's going to be that way. There's actually a session later today on durable functions that will talk about some of the other stateful patterns. But just a simple example. In fact, if I wanted to go one step further, I could take this function, again, since it's completely open source, and using the Azure Functions tooling, I could run a command here. It's a little blasphemous of a command, but I can run it, which is, hey, take that open source function, and instead of running it in the serverless cloud, I'm actually going to deploy it to Kubernetes. Because for whatever reason, I've decided I want it to run that context. Now, I completely agree, this is not the optimal way to run functions, right? You lose a bunch of the serverless benefits by running your functions in Kubernetes. But for those scenarios, for those requirements, for those companies that maybe aren't quite to that rung of the ladder where they can use a fully managed service like functions, we wanted to allow this effective programming experience for every developer. So if I now say to my Kubernetes cluster running in Azure in this case, hey, tell me about it, you actually notice after that deployment, I have that function running. It's even scaled itself down to 0, and it's ready to run, in this case, in a Kubernetes cluster, the same way that it would run in the cloud. So the reason I show you this is just to say, yes, there are deterrents today, but they're all going to start to fall down. So keep an eye on this space. Now, the tech side of this is only one half of the equation. The other big piece of the puzzle is around public perception and community. Now, if we go back to the story of electricity, there's one really interesting figure here, which is Harold Brown. If you look at his picture right there, Harold Brown was in New York, and he did not think that electricity, AC-powered electricity, was a good idea. And in fact, to make his point known, he did a presentation where he got on a stage, much like the stage I'm on now. He got a bunch of stray dogs on that stage. And he said, do you want to know how dangerous electricity is? And he pulled the switch, and he electrocuted every single one of those stray dogs on stage. He did it again later with a horse, I think. And the crowd was just terrified. And he's like, do you really want this same electricity running in your homes with your kids? And it was really effective in scaring people. In fact, George Westinghouse was one of the people who was trying to build out infrastructure for AC electricity. And Harold Brown really didn't like this. So there was even a discussion at the time in New York where they're like, hey, we need to find better ways. Ugh, that's a terrible word. We need to find better ways to execute our prisoners back in the 1900s. And so Harold Brown with a group of people was like, hey, I've got a great idea of how you can get rid of prisoners. And this was like the birth of the electric chair. But the part of the story that terrifies me the most is that Harold Brown was actually effective in coining the term so that when a prisoner was electrocuted, when they were executed through electrocution, they actually called it being Westinghoused for a really long time. Can you imagine if there was like a major cloud outage and they were like, oh yeah, today Target has banned Serverless and their company is completely down, right? So there was a bunch of fear-mongering happening. There was this huge dialogue happening trying to sway public perception. And luckily, on the other side of the dialogue were people like Nikola Tesla. And during the same time, Nikola Tesla did a presentation in front of a crowd just like this one, where he got fatal doses of high voltage electricity, but he emitted them through a Tesla coil in a very safe, high-frequency way. And he was able to show to the people, hey, I can walk, I can interact, I can be right next to this electricity, it can flow through me, but it's completely harmless. It's all about how we use this that's going to make the difference. And that was a huge turning point when Nikola Tesla was able to do these demonstrations. So the reason I talk about this in the world of serverless is because every driving point for every tipping point centers around people. This is Malcolm Gladwell's central point in his talk as well, around you need people who can connect with others, you need people who can promote the good ideas. Yes, you need a good product at the end of the day, but you really need people. So when I look at Melbourne, when I look at Sydney, when I come to Australia, I really truly mean it where I think there is something incredibly special happening here, something very unique. And I don't know if you realize it, but I 100% notice it, and I say it every time I come on a trip to Australia. There's something here where for some reason, this community, this group of companies, you seem to be ahead of the curve in a lot of ways. We see it like qualitatively in our data. Australia has tremendous serverless growth compared to the rest of the world. Now, I'm hoping that as a community, we can leverage that and work to tell others about the dialogue. We can't let anyone else write the dialogue for us. We can't just let people who are afraid of changes, who have fear, uncertainty, and doubt, write the story for us. So a few things that I hope that all of us take to heart. Take time to try new things, right? If you've only ever used AWS Lambda, go try using Azure Functions. If you've only used Google Cloud Functions, try writing AWS Lambda. If you've never done anything with some of the Kubernetes stuff, give it a shot, right? We've got to try new things. We need to explore and figure out how to work well in this new world. And as you're doing that, share your learnings. I really hope that at the end of the day, as you hear a full day full of incredible talks, that a good few of you go and write some blogs about it. Go and share on Twitter. Go say, here's what I'm learning about serverless. Here's how I'm thinking about using serverless. Make your voices heard today more than ever. And share your feedback too. When you run into issues, don't feel like you're writing marketing for Lambda or marketing for Azure Functions. If you've hit something that you don't like, if you hit something that you think should be improved, make some noise around it. I know personally, I love reading blogs where it's like, hey, here's how I used Azure Functions, and here's all the stuff that I wish was easier or better. It's not going to hurt anyone's feeling, but it helps move the dialogue forward. So we all need to be actively engaged. We cannot be passive in this. In fact, just recently on a podcast, Screaming in the Cloud with Corey Quinn, there was a guest, Richard Campbell, actually this last week, and he had this quote that I loved. He said, the cloud is reshaping what humanity is going to look like, and our small roles in it, whether you're building it, utilizing it, or talking about it, are all part of moving that ball forward. Now, the reason I think this matters, and I know you're up here and you're like, yeah, Jeff, you work at Azure. Of course you want people to use serverless because you're the product manager for Azure Functions. But it truly is more than that, because I don't get excited waking up every day thinking, oh, hey, there's a product and I want to see it grow, right? The reason I get excited about serverless is because I truly do believe that as compute continues to evolve, And as serverless begins to move forward, it will have true and lasting impacts on how we're able to build systems. Just one last story. This one's from a few years ago. I don't know how many of you remember this, but about 2 years ago now, there was a hurricane in Puerto Rico, an island right off of the United States, Hurricane Maria. It was a terrible disaster. Thousands of fatalities, billions of dollars in damage. It was awful. And right after it happened, Microsoft reached out to the government and they said, hey, we want to help where we can. Is there anything we can do to assist in these efforts to help these people who've been struggled with the after effects of this hurricane? And the government said, you know what we could actually use is some data, especially data around maps. We need to know where to target our efforts. We only have a certain amount of people here who can help us. So that team got together, time was of the essence, and they tried to figure out how can we use this data to help in this time of need. And what was incredible about this story was that in a number of hours, they were actually able to use serverless technology to crawl social media. Because they learned an interesting trend was that people were posting to Facebook, to Twitter, to say like, hey, we need help. This is a terrible disaster in this area. And using serverless tech in a matter of hours, they were able to get a fully scalable app, a real-time map that they were able to share with the relief efforts and say, okay, here's where we're getting the most social traffic with people tweeting that they need help. So maybe this is where you should target your efforts, and use that data to assist in the real impact of real lives. Now, that's the type of problem that traditionally would have taken a bunch of time to build systems and infrastructure and integration to scale to data of that kind. That was possible in just a number of hours as compute started to become a utility. So I truly do believe that serverless has the power to change the way that we can save lives. In the same way the impact of electricity would have on a hospital, serverless enables us to meet the needs of customers, to help people in ways than never before. But it's really going to depend on the people and our part that we play to shape that future. So I hope you enjoy your whole day here today. We have incredible talks. Take notes, be involved, be an active member, and I'm hopeful that we're going to see that serverless tipping point. Thanks so much.
Thank you very much, Jeff.